In order to write the equation of a linear function in slope-intercept form, we may have to take our equation and solve it for y. So if it's not already solved for y, it must be solved for y to get it in y equals form. And when you do so, please be sure to distribute your multiplication and division to all the terms. So in example 5, you'll notice that we don't have the equation in y equals mx plus b form. So in order to get it in y equals mx plus b form, we have to subtract off 2x from both sides. Rewriting the equation, we now have y on the left side and negative 2x plus 4 on the right side. Our slope is the number that is the coefficient of x. That's negative 2. I'm going to rewrite that as a fraction, negative 2 over 1. The number that's added to negative 2x is b. That's our y-intercept, and that is 4. So when I graph the line, I'm going to start at 4 on the y-axis, and then use my slope to rise negative 2 and run 1 to graph another point. Then I'm going to continue that same pattern, down 2, right 1, down 2, right 1, all the way to the end of the grid. And we can go in the opposite direction, up 2 and left 1, to fill in the rest of the grid. Then next I'm going to connect all of those points and put arrows on the end of my line. In the next example, we again have to solve for y in order to graph this, so I'm going to subtract off 2x to begin with. We're trying to get y by itself. So the resulting equation is negative 5y is equal to negative 2x plus 10. The next step will be to divide by negative 5 to get y by itself. So on the left side, we have y is equal to, now here's where I have to be careful to distribute my division. Negative 2 divided by negative 5 is positive 2/5 times x. Positive 10 divided by negative 5 is negative 2. So my slope is 2/5, that's the coefficient of x. My y-intercept b is the number that's added to 2/5 x, which is negative 2. In order to graph, we're going to start at negative 2 on the y-axis, and then use the slope to graph more points. So there is a rise of 2 and a run of 5. That takes me to another point. We're almost to the end of the grid, so now I'm going to go in the opposite direction, down 2 and left 5 to graph another point. That gives me enough points to put in a nice graph of a line fairly accurately. In the last example on this page, we're trying to get y by itself, so we have to subtract off x from both sides. That leaves us with negative 2y is equal to negative x plus 4. The next step to get y by itself is to divide by negative 2. So on the left side, we have y by itself. On the right side, we have to distribute that division of negative 2. Remember that there is a ghostly 1 in front of that x, so what we're really dividing is negative 1 divided by negative 2. A negative divided by a negative is a positive, so that's positive 1/2 times x. And then for the second term, 4 divided by negative 2 is negative 2. So our slope is equal to 1/2, that's already a fraction. Our y-intercept is negative 2. In order to graph that line, we'll go to negative 2 on the y-axis, and then use our slope to graph more points. The rise is 1, and the run is 2, so I will go up 1 and right 2 to graph another point, and then continue that same pattern until I fill up the grid. Up 1, right 2, up 1, right 2, or in the opposite direction, down 1, left 2, down 1, left 2, down 1, left 2. Then I'm going to connect the points with a smooth graph and put arrows on the end. In the next example, we'll see some graphs of linear functions, and we'll write the equation. So we're really doing the same thing, but backwards. So let's take a look at our graph, and let's see if we can identify the slope. Remember, the slope is the rise over the run as we go from one point to the next. So the rise over the run that I just indicated right there is up 2, that's a positive 2, and right 2, also a positive 2. So that means that the slope is 2 over 2, or 1. B is the y-intercept, and so that's the place where the graph intersects the y-axis. So our b value is -3. If I want to write my equation from there, my equation is going to be y equals 1 times x minus 3. So I'm going to simplify that to rewrite it as y equals x minus 3, since 1 times x is x. In the next equation, let's identify the slope. As I move from one point to the next, my rise is -2 and my run is 1. So that means that my slope is -2 over 1, which equals -2. My y-intercept is the place where the graph intersects the y-axis. So b is equal to 0. So slope is -2, and b, the y-intercept, is equal to 0. So if I write my equation, it will be y is equal to -2x plus 0. We're going to simplify that to rewrite the equation as y equals -2x, since when we add 0 to something, it doesn't change its value. In the next example, we have a slope that's equal to rise over run. The rise is -5 and the run is 3. So that means that our slope is -5 over 3. And our y-intercept is the place where the graph intersects the y-axis. So our b value is 4. Writing the equation, y equals -5/3 x plus 4. In the next equation, or the next graph rather, our slope as we go from point to point is up 0 and over 3. So our slope is 0 over 3, which is equal to 0. So slope is 0. And the y-intercept is the place where the graph intersects the y-axis. So our b value is 2. Our equation will then be y is equal to 0x plus 2. We're going to simplify that. 0 times x is 0, and 0 plus 2 is 2. So the equation simplifies to y is equal to 2. In the next example, a graph of the line is shown, and we're asked the question, why can't this be written in slope-intercept form? So let's think about when we go from point to point on the line. To go from one point to the next, I only rise a negative amount or a positive amount, depending upon which direction I'm going. But the run is equal to 0. So our rise is equal to -3, the way that I've drawn it, and our run is equal to 0, which means that our slope is equal to -3 over 0, which is undefined, since we cannot divide by 0. Also, this graph has no y-intercept. You'll notice that it does not intersect the y-axis. So if there is m does not have a value, and b does not have a value, then we can't write the equation in y equals mx plus b form. when we are writing equations that are a result of a word description, certain phrases and words may clue you in to what each value represents. For instance, a y-intercept can be thought of as a starting value, or sometimes we may say initial value. The slope is the rate of change. So in the last example, each of the quantities describe changes at a constant rate. We want to write an equation that relates the variables. So a balloon with initial volume, 5 cubic feet. So that will be our y-intercept, or the b value, loses volume at a rate of 2/3 cubic feet per minute. Be very careful with this because it says it loses volume. That means that the volume is decreasing, and that means that our slope is negative 2/3. So our equation would look like this. Y is equal to negative 2/3 x plus 5. Now, what I'm going to do next is I'm going to substitute to write the equation in terms of the variables that were given. The initial value is a value of the volume. So that means that the volume is the y variable, or the vertical variable. And t is the horizontal variable. So when I rewrite my equation, I'll rewrite it as v equals negative 2/3 t plus 5. In the next example, a car starts 3 miles from home and moves farther away at 20 miles per hour. So the starting value is 3, that's our b, and the rate is 20 miles per hour, so that's our m. If we're moving farther away from home, then the distance is increasing, and that's going to be a positive rate of change. So if I write my equation using that information, it will be in the form y is equal to 20x plus 3. Now I'm going to replace the y and the x with the variables in the problem. The y variable, which corresponds to the initial value, is the amount of miles, or d. The x variable then will be time, or t. So d is equal to 20t plus 3 is the equation that describes that relationship. In C, we have a velocity of 35 miles per hour. That's going to be our rate, which corresponds to an m value. Oh, this is an interesting problem. That sounds like a rate, but it's actually not, because what they're telling us is that the velocity does not change. So that means that this is a 0 rate of change. Then we look very carefully, that 35 miles per hour is the initial velocity. So that's actually a b value, or the starting value. So if we write our equation, then the equation is y equals 0x plus 35. Or, since 35 is a value of v, then the y variable corresponds to v. So v is equal to 0t plus 35, which could be simplified to an equation that would be written v equals 35. And we can get that by just multiplying the t times 0. T times 0 is 0. 0 plus 35 is 35. So what that means is v, the velocity, is 35, and that never changes. So that's what the equation says, v just equals 35. In the last question, a test with no mistakes earns a grade of 100. 4/5 of a point is deducted for each question missed. So this teacher starts his students at a b value of 100 and then deducts points at a rate of 4/5 of a point per question. So that's going to be our rate, or our m value. So if we write our equation, y is equal to 4/5 x plus 100. Now, there's a detail here that I've left out, and that is there's a deduction of 4/5 of a point. That means that our rate is negative 4/5. And so now I'm going to substitute the variables in the problem in for y and x. The grade g is the one that starts at 100, so g corresponds to our y value, and that's equal to negative 4/5 times m, the number missed, plus 100.